Yeah, good morning to one and all. I'm Navin Kumar Sriramoju. So, in the previous class, we have seen the definition of machine learning operations and understood what is the difference between machine learning subject and machine learning operation subject. And in the process, I have told you that in order to get some expertise in the subject called as machine learning operations, we need to have the knowledge of some existing subjects such as machine learning, such as DevOps, and such as data engineering. So, in the process, I have told you that we will have some small discussion on the prerequisite subjects, and this video is one among them. So, which will discuss about the subject called as DevOps, and understanding this will be helping you to understand machine learning operations more clearly and more easily. So here, this is the introduction of the subject called as DevOps, and it is said to be a software development methodology that combines development and operations to improve the collaboration between software development and IT operations. So it happens like earlier we used to have separate dedicated teams for software development and dedicated teams for IT operations, so that if these two teams work parallelly and will work in a coordination, then the software product delivery will be on time and will be having high quality. And it happens like these two teams are not collaborating properly, and which may lead to many unwanted problems. So, in the process of overcoming that, they have brought up a new role called as DevOps engineer, who will be looking after the development part of a project, and who will be also behind the section called as operations, so that the software that we are going to deliver will be of high quality, will be delivered fastly, and will be more reliable, so that more people may get attracted to it, and there will be some continuous improvement throughout the process. So here, the DevOps is a culture, set of practices, and collection of tools in order to give high quality software. And these are the phases that we are going to see in the concept called as DevOps. So, development phase, we are going to see test phase, deploy phase, operate phase, monitor phase, and improve phase. So, we'll talk about all this in the coming slides. So this is a slide which will be telling you that what exactly a traditional software will do, and how the problems that we are going to identify in traditional software are being addressed with the subject called has introduction of DevOps. So here in traditional development, if at all you talk, we may see problems like slow software releases due to the bad coordination between the different type of teams involved in the project development. Second is since it is a traditional technology may not be used to the mark, and we may see the manual involvement, and when manual involvement is seen, there is a prone of errors happening. And since the technology is not used much, there the process will be very slow, and which will result in long testing cycles. And if at all they identify some problems also, it will take much time to understand what is the type of problem they are facing, and will take time to fix the problems. So these are the problems that we are going to face in traditional development, and some of these problems, so majority of these problems are been addressed with the subject called as DevOps. And DevOps address the problems and give the uh, outcome like faster software releases due to single teams or unique teams working on the projects, better collaboration between the teams, since technology is used to very good extent, the systems are automatically updated, and everything will be done automatically, and the process is automated. Faster testing will be done because we identify the problems faster, and we can fix them fastly. So this is the main target of DevOps, and which is said to be a very better option when compared to the traditional development process. And this is the life cycle of DevOps concept. Like first we plan something, then we develop in the form of writing some code, then we deploy in the form of making or building some packages. So then we go for testing, so that we will ensure that whatever we have written is properly done, and we will promise a good amount of quality to the customers who are using it. Then we will release a version, right, so that the customers start using it and give some feedback type of thing. Then we'll deploy in a large scale. Then we do some operations, like we will be checking the status of the application. We will be checking and monitoring the response given to the applications, and if at all any issues are identified, we try to address them. Then we'll go with monitoring, then we'll take some feedback, so that it will be helping us for continuous improvement. So this is actual life phase. So we'll talk about each one phase in detail. The first phase is called as planning phase. So we gather some information and we'll plan according to the given budget, given set of requirements, given mindset of the customers, and given understanding of the stakeholders. So when we do some planning, and we have already told that to much extent we are going to use technology. So here also, in each phase of development operations, we are going to use some tools here. You can use any one of the tool listed in these slides, so that your work will be automated, your work will be fast, and the delivery will be up to the mark and of high quality. So we are talking about an application or tool called as Jira. It is said to be a project management and issue tracking tool used by teams to plan, track, and work accordingly. The second type of tool for planning is Trello, which is a visual project management tool that use dashboards, that use lists to organize the tasks and collaborate with teams, so that organizing is concentrated more here. Then if these two are not suitable for us, we can go with the next one called as Azure boards, which is like a tracking service, which will work in an ecosystem called as Azure DevOps, that will be helping us to plan, manage, and monitor the development within the ecosystem called as Azure ecosystem. So once this is done, we are going into the next phase called as development phase, which will be concentrating on writing application code using some programming languages. So here actual the role of software developers will come into the scene, where they'll start writing the code. And these are the general activities that we perform. Once someone writes the code, we'll review it whether it is up to the mark or any corrections are needed. And if at all corrections are needed, so we will be having the all versions of the code written in the form of a repository, so that if at all a new version is not working properly, we can roll back to the earlier version. And for this we are going to use tools called as GitHub, GitHub Lab, or Bitbucket. So these are all the different type of tools used here. So for storing the code, amount of code written by the users, right? Now the next one is build. So when here I want to tell you one point, like when you're writing a code for a single program, we'll write some code, we'll save it somewhere. And when we are developing a software application, it is said to be the combination of different codes, right? One will be used for login purpose, one will be used for registration purpose, one will be used for logout purpose, one will be used for viewing the dashboard purpose. So here each page should be working in understanding with the other page, that is called as navigation. And if at all navigation is properly done, then the application is said to be working properly in a sequence of actions that we going to perform on a web portal. So here, so when some people or some developers develop some sequence of codes, then those are being collected towards a single point of contact, and they will be trying to convert these lines of code or pages of code into a single so-called application. And we will try to bring up the first copy of the application here. And for that also we have some tools here. Maven is one tool, is a built automation and dependency management tool primarily used for Java applications. Gradle is one tool. It is a flexible built automation tool that supports multiple programming languages and enables faster customizable builds. So here Gradle is generally used in Android Studio. Then the next one is Apache Ant, a Java-based automation tool used for uh, files to be configured properly according to the requirement. So once this is done, we are going to next phase called as a continuous integration. So here it happens like when we develop the application in its primary status and we release that into the market, we'll try to get some feedback, and based upon the feedback we are trying to either delete some options that are not required by the customers, or we are going to add some new features that are being exactly required by the customers. So here we will try to integrate that in the process of changing the code, changing the status of the application time by time, and ultimately satisfying the client in the form of giving the requirements mentioned on a page. So, developers frequently merge code changes into a shared repository, and automated builds and tests are run to detect issues early. So, here, this process, this phase of continuous integration is all about making the application to run properly. At the same time, try to identify the issues that we are going to face while deploying, while training, while testing, while giving this to the actual use of the customers, right? And what are the benefits of doing this? The benefits are we will identify the bugs at a very early stage so that the loss will be minimum. Then we can add new things very fast in the form of faster integration, and the code whatever we write will be exhibiting in a better quality. And for this also we have some tools here. The first type of tool is called as Jenkins, right? It's an open source automation application. The next one is GitHub Actions. It is an CI/CD, continuous integration, continuous development platform that automates workflows such as building, testing, deployment. Code can be directly done from repositories. And the next one is GitLab CI. It's an system for continuous integration and delivery system in such a way that it automates the software development, testing, and deployment phases. And these are the different type of phases. Okay, so this need not to worry about. And once this is done, so we'll go into next slide here where we are talking about testing. Okay, testing is like we'll be having two types of testings here. One is manual testing, which will take a long time to execute, and we have the automated testing nowadays increasingly using by the developers. So here testing phase will be all about automated testing, which verifies the application works as expected or not. Okay, so here we have different type of testing here. One is called as unit testing, one is called as integrated testing, one is called as functional testing, and one is called as performance testing. So all are working towards testing the application and telling whether the application will be of any use or not. So here in testing we do also have some type of tools here. One is called as Selenium. So Selenium is an open source framework for automating web browser or uh, testing across multiple browsers. JUnit is one type of Java testing framework used to write and run unit tests for applications. And the next one is TestNG, a type of Java testing frameworks that provides advanced features such as test grouping and parallel execution. So here in these three applications tools, we are talking about Java. Why? Because out of 100 applications we are developing, majority up to 80% of the applications are developed using Java. So majority of the tools also developed only for catering the services, catering the needs of the Java applications. Right. Once this is done, we are going to a continuous deployment phase where after successful testing, the application is automatically deployed to production or staging environments. And here, these are the three types of deployment methods. One is called as blue-green deployment. The one is called as scanner deployment, and the next one is called as rolling deployment. So here, blue-green deployment is a release strategy that switches traffic between two identical production environments to enable seamless updates with minimal downtime. So while updating, generally systems will go down and the server will be shutting down. After giving the updates, then again system will pick up and system will come into the actual usage. So here, without doing all that also, you can do something but like updating the system with minimum downtime is done in blue green deployment. The second one is canary deployment, where it is a strategy that gradually rolls out to a new application version to a small group of users before making it available to everyone. It's like suppose we have 100 people in the market. First, the deployment version or updated version will be given to only 10 to 15 people. Based upon the feedback given from them, we will be trying to make some changes and we will be making it available to the all other for people in the market. And the third one is rolling deployment. It is a strategy that updates application instantly increment instances incrementally, replacing old versions with new ones without taking the entire system offline. So here one side the old version is available, on the other side the new version also will come into the use, so that the user may not face any server issues while using the application, right? And the seventh phase is called as operations phase. The application is managed and maintained to ensure that it runs smoothly, and the activity generally we see are server management is one type of activity that we see here in the operations phase, then infrastructure maintenance phase, and security updates. So these are the three things that we have to monitor 24 by 7 in order to give proper services to the customers, services to the software companies. And these are the benefits we do have. One is high availability, ensure that application is always available, that means every time it is on work. Then reliability, you can depend on it and you can store your data online. Then performance, you will be trying to optimize the performance of the application so that the user will have better user experience. And the security, which will keep the system secure and up to date. Once this is done, we'll talk about the next one called as monitoring. Monitoring is about the application performance and infrastructure health are continuously monitored, right? So generally we'll talk about what is the status of CPU, what is the status of memory to be used, what is the status of applications response time, how many errors that we are going to see, and what is the concept of system availability. So these are some tools we are using here in this phase called as monitoring. Prometheus is one type of tool for monitoring and alerting the data and sending the information or updates time by time. Then the second type of application is Grafana, an open source virtualization visualization platform to use interactive dashboards for monitoring and analyzing and for better understanding in simple words. Then ELK Stack, a log management and analytics platform consisting of information collected, searching and visualizing log data. And the next one is called as Nagios, a type of infrastructure monitoring tool that tracks the health, performance, and availability of the server, availability of the applications, and availability of the network devices. And these are the benefits. So benefits are this: real-time visibility into system and application performance, early detection of issues and proactive alerting, improved performance and user experience, and higher availability and reliability of the systems. So once this is done, so we'll talk about the pipeline. So this is how the exact thing happens in the DevOps. So first phase is a developer phase where developers write and commit code. The next one is GitHub repository, then continuous integration, automated testing, continuous deployment, production server, monitoring and feedback. So once this is done, we'll talk about the difference and we'll close here. So generally, when I have discussed the subject, somewhere I have spoken about DevOps lifecycle, and somewhere I have spoken about, I have used a term called as DevOps pipeline. So people may be using this interchanging. That means sometimes in the place of lifecycle, they think pipeline is appropriate word, and they think that both are same. But though both are same to some extent, there are some minute things that differentiate between both of these, and this is the simple definition and we'll close here. So life cycle refers to a complete sequence of stages from beginning to end, and pipeline refers to a series of processing steps through which work will flow. And life cycle will be focusing on entire journey, whereas pipeline will be focusing on execution of the tasks or data. The scope of life cycle is to check whether stages are properly representing the phases or not, whereas in pipeline, the stages are typically operational and may run continuously or in parallel. So these are the examples here. So this is all about today's class. So we'll be talking more on the subject in the coming classes. Thank you.